Let's start with questions from homeworks or whatever. To this point in chapter 4, we've done worksheets 1 and 2. We've assigned 1 through 16, and we've added delta math, right? And worksheet 4, and worksheet 4, yes. Questions on any or all of that? What do you guys got? Anything so far? Nicholas. Yeah.
Can you do number 3?
Which worksheet are we looking at?
Worksheet 4.
Worksheet 4. Okay. And you said number 3? Okay. All right. So remember, can we stop talking, please? We start from the inside, and remember that all these sine inverse or arc functions all give us an angle measure, right? So I know that tan inverse, same thing as arctan, is going to give us a theta. Well, let's write it over here. So I can say then that tan theta is equal to x. Now in a right triangle, that's a terrible looking right triangle, Mr. Kulik. What is tangent equal to? Opposite over adjacent. Again, that's just SOHCAHTOA. Should you be able to yell that out like on cue immediately?
TOA.
Definitely.
TOA.
TOA. So when I look at x over 1, it has to equal opposite over adjacent. So the opposite side should be x, and the adjacent side should be 1. I'm then going to do the Pythagorean theorem to figure out this third side. So when I write the Pythagorean theorem, I remember that the hypotenuse is our c. So I have a squared plus b squared equals c squared. So to solve for y, we'll just square root both sides. So y is 1 plus, the square root of 1 plus x squared. So now I'm going to do cosecant theta. Now, cosecant theta is 1 over sine theta. And what is sine? Opposite over hypotenuse. So cosecant should be the reciprocal hypotenuse over opposite. So the hypotenuse in this case is square root 1 plus x squared. And the opposite is x. So that's it. Does that feel okay?
Yeah.
And again, these shouldn't be too hard, right? Like the hardest part is like getting over, they're like, okay, I'm just using the inside to build the right triangle. And then I use the outside to evaluate, or I evaluate the outside with the right triangle that I just built.
Let's say if you like subtract the 1, y by itself, could you just square it again and become like positive?
Okay, say that one more time for me.
So if like, for example, you like solve for y, and then like you just subtract the 1s, would it become positive? You able to square it?
So I have y squared plus 1 equals x squared or something.
Yeah.
So I'd subtract the 1 over. And we just square root both sides. It just is what it is, right? Is that okay?
Yeah.
That's what you're asking for, though, right? Okay. I just wanted to make sure that, like, I understood your hypothetical, because sometimes you guys say it and you say it quick, and I'm like, wait, hold on, okay. I'm like, so it's not anything to do with this particular problem, it was some other. Got it. Good. Okay. You're happy, I'm happy, we're happy. Very good. Others from homeworks. Emily. 5 from the same sheet?
Yeah.
Is that on the other page, though, it looks like? No problem. So this one, you're going to have to be a little bit careful when we do the Pythagorean theorem part. So again, same idea. I have that theta is cosine inverse of 3x. So cosine theta is 3x. Cosine is adjacent over hypotenuse. So when we draw our right triangle, our adjacent side should be 3x. Our hypotenuse is going to be 1. And now we do the Pythagorean theorem to find that third side. So a squared plus b squared equals c squared. Again, remember c must be the hypotenuse. So 3x quantity squared, what do I get when I do that? 9x squared. Remember, that's 3x times 3x. And then we'll subtract the 9x over, or 9x squared over, and square root both sides. So far, so good, Emily? And then if I do sine of theta, that is opposite over hypotenuse. It's too messy. It's better. Or you could just write that as square root 1 minus 9x squared, right? You don't need to include the over 1, but does that feel good? Okay. Nick?
Either 6 or 7.
Yeah, does anybody have a preference on whether we do 6 or 7? If you do, holler. Nobody does? 6? 6? 6? 7? 7? Okay.
6.
You guys are just being boogers now. All right. 7. I'm going to do the same thing. I'm going to start by the inside is my theta. So cosecant theta is 2x plus 1. And remember, cosecant theta in a right triangle is the reciprocal of sine. So instead of being opposite over hypotenuse, this should be hypotenuse over opposite. And I don't mean, I said it was the opposite of sine. I should have said it's the reciprocal. So 2x plus 1 is my hypotenuse, and the opposite side is 1. So that base of my triangle should be my y. I'm going to do my Pythagorean theorem. So I have y squared plus 1 squared equals 2x plus 1 squared. So 1 squared, well, that's just 1. How do I do 2x plus 1 squared? FOIL. Remember, that's 2x plus 1 times 2x plus 1, right? So when I FOIL that out, I'm going to get 4x squared plus 2x plus 2x plus 1. If I subtract 1 from both sides and combine some like terms at the same time, I get that. And then we'll square root both sides. And if you're feeling fancy, notice in the inside, there's a greatest common factor of 4. Do you guys see that? And I know that the product of two radicals is the product of its radicands. So I can break a square root at a multiplication symbol. And that's nifty because the square root of 4 I know is just 2. It's the same thing we do if I wanted to do like the square root of 18, right? I think about that as just square root 9 times square root 2. Square root of 9 is just 3. Same idea, right? It's just variables involved instead of just numbers. So far, so good, Em? Or I guess Nick was asking about this. But it seemed like you chimed in and wanted 7 over 6. Okay. So then we'll do cotangent of theta. Cotangent, I know, is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent should be adjacent over opposite. So my adjacent side was the y that we just found, and my opposite side is the 1. And we're all good. It's like half the sheet done now, right? Look at how fast that is. This would have taken you 10 minutes, guys. Boom. I'm just teasing. Of course, I can do it much faster than you can. It's had a lot more practice, you know? All right. On to new stuff. Okay, we have one more topic to cover in chapter, or that we're going to cover in chapter 4. Yes. So let's take a look at that. There's just one little piece of new vocab, and the rest of this is going to be just using ideas that we've already developed. So there's not a lot to this section either, which is lovely. I love those sections where it's just like, okay, we're just going to keep using the stuff we've already developed. So there's 2 new terms that we're going to talk about called angle of elevation, angle of depression. I'm not going to define these 2 things in words. I'm rather going to define these with a picture. So let's say we have one person that's standing on the ground and one person that's like up on a ledge. If they both look straight ahead, these are their lines of sight, right? If the person on the ground tilts their line of sight up so that they can see the person on the ledge, this angle that's formed is called an angle of elevation. So if your person is looking straight ahead and has to look up to see it, the angle formed between their line of sight when they're looking straight ahead and their line of sight as they tilted their head up is called the angle of elevation. So far, so good. Now let's take the person on the ledge. Again, this person on the ledge is looking straight ahead. If they then change their line of sight so they can look at the person on the ground, they tilt their head down. So our angle goes from the line of sight straight ahead to the line of sight down. That's called an angle of depression. Everybody okay with that? The number one mistake students make is they put the angle of depression here. Rather than putting it between the line of sight, or the 2 lines of sight, you guys want to, over and over again, put the angle of depression between the vertical and a line of sight, rather than between the 2 lines of sight. Okay? So be cautious of that. That's the only new idea here. what we're going to be doing problem-wise in this section is story problems. Yes, I love story problems. Should we call them math stories instead? Does that sound less scary? Scarier. Okay. Well, that's two positive words together, though. Like math, that's something good, and story, that's something. It's math stories. Hi, Brooklyn. Thanks, dude. Jacob. It's for you. That was a weird sound that just made. All right, let's read the problem here. It says, Christy is looking up at the Fisher building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to be 66 degrees. How tall is the Fisher building? You get a problem like this, what's the first thing we should do? Draw a picture of the situation, right? It's describing a physical situation. So here's Christy. Here's the top of the spire. It says it's 200 feet to the base of the building. And our angle of elevation is 66 degrees. Where does that angle go? In the inside the triangle at the bottom, right? Now there's one other piece here in our picture that we should include that wasn't included in the description, but we can assume it should be a right triangle. Why can we assume that this is a right triangle? You ever seen a building that wasn't built straight perpendicular to the ground?
Tower of Pisa.
Yeah, but we're in Detroit, so we know it's not that. Fair enough. And now what is it asking for? It wants to know the height of the building, right? Which side does represent the height of the building? The other leg, yes, the opposite side. So I'm going to call that X. Everybody good? Okay, well this is just a right triangle, right? We know what to do with this. So relative to our 66 degree angle, the side we know is opposite, adjacent, or hypotenuse. Adjacent. And the side we want to know is opposite, adjacent, or hypotenuse. Opposite. Which trig function should we use that relates opposite and adjacent together? Tangent. So I can write tan 66 equals opposite over adjacent. Yeah, so if you think about this as a proportion, this is the only time you should ever be cross multiplying is to solve an equation where you have one fraction equal to another fraction. X times 1 is X, and 200 times tan 66. So I'm just going to get out my calculator and type in 200 times tan 66. Why don't you try that with me right now? Ah, that's the question I was hoping that no one was going to ask until we did it. Yeah, we should be careful, right? What mode should our calculator be in for this problem? Degrees. How do I know that? The angle in the problem was given to us in degrees. So I'm going to press the mode button right next to the blue second button there at the top and change to make sure degree is highlighted. So just use my left, right, up, and down arrows and press enter to highlight the degree. Then I'll exit out just by pressing second and the mode button again. And then I'll type in 200 times tan 66. And I get about 449.2. Bloop. And we're done. What do you guys think on that? Well, that is it. What's the hardest part? Getting the picture, right? Degree mode. If that's the hardest part for you, good on you, my man. All right, let's do another. This one says, Jane has climbed a tree and is looking down at her friend Mary. Mary has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far from Mary, or how far is Mary standing from the base of the tree? So there's Jane up in the air. Here's Mary on the ground. Trees go perpendicular to the ground. We're 17 feet up. Here's our line of sight from Jane to Mary. Says the angle of depression from Jane to Mary is 49 degrees. Where does the 49 go? You think right here? That's wrong. The 49 is here between her line of sights, right? That's the place where students typically mess up. So how is that going to help us? Okay, so you could call this one 41. You could also think about that. And if we're looking for, if we're looking for that side, it's the same as that side. Or, if you remember your geometry, if you have two parallel lines that are cut by a transversal, we know the opposite or the alternate interior angles are congruent. So I know that angle also is 49 degrees. So whichever triangle you would like to use, whether you're using the black triangle that we drew with the 41 degree angle, that's fine. If you want to use the yellow triangle I drew with the 49 degree angle, that's fine. If you want to use the black triangle with the 49 degree angle that we added in blue, that's fine. Any of those are going to get you the same answer. The setup will be a little different in the equation that you solve, but you could draw any of these pictures and it would be fine. What you can't do is label that angle that's 41 degrees as 49 degrees. That'll get you the wrong answer. So far, so good? All right, let's say that we're using the yellow triangle. So relative to that 49 degree angle, the side we know is opposite. And the side we want to know about is adjacent. So we should be using tangent. So I can say tan 49 is equal to 17 over x. So again, I'll do my little cross multiplication thing. So I get x times tan 49 equals 17 times 1. That gets rid of the fractions. And then to get the x by itself, we'll divide by tan 49. And it's calculator time, my homies. 4.7, or well, I'll call it 4.8, 14.8. Boy. And I think we're in feetsies. How's that feel? Again, I wanted to point out to you, like, the most common mistake, right, is mislabeling your triangle with an angle of depression. Be really careful about that. Almost always when we draw these triangles, your angle of depression is not going to be inside the triangle you drew. Everybody's cautious on that. We see what I mean? We all made the mistake right on. It's an easy mistake to make. Just have to be careful. All right, one more example. This is the worst case scenario, is the algebra gets a little bit messy on this one. Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? Well, let's see. Let's draw some picture here. So there's our first measurement. There's our second measurement, and we went 100 meters closer. And then we're looking for how tall the tower is, the Eiffel Tower. That's X. Doesn't really seem like we have enough information here, right? We do, but the algebra is going to get a little yucky to get to where we want. When I see a problem like this that looks like I have two triangles, like one inside of the other, nested together like this, what I'm going to see is, or what I vision in my head, is two separate right triangles. I picture this one, and then I picture that one. Everybody okay there? Notice that this part of the triangle, or that part of that side, is in both triangles. I'm going to give that side a name. I'm going to call it Y. And I'm going to redraw the two triangles now down here below, just so we have a clearer picture. I'll call that B so that these triangles have names. So this first triangle, the side P1B should be 100 plus whatever this Y is. Is everybody okay with how I came up with that? Now, if I look at the pink triangle, that's P2, BE, 37.5, X, that's just Y. So if I look at this first triangle, if I'm using the 32-degree angle, the two sides we know anything about are opposite and adjacent, correct? So I can write tan 32 equals opposite over adjacent. The problem is I can't solve that equation because I have two variables in it, right? If I look at my other equation and I use that 37.5, again, I know the two sides I know something about are opposite and adjacent. And both of these two equations have to be true at the same time, right? Because these two triangles are part of the same picture. So what I can do is I can take these two equations together and think of them as a system of two equations. Now, you guys studied how to solve systems of two equations last year, you would have talked about at least 3 good methods to do this. Who remembers one of those 3? Elimination, great. What else do you remember? Great. The other one that you forgot about was graphing, would have been the first one, where you'd graph the two lines and find the intersection. And then you might have talked about some matrix methods after that, right? Solving a matrix equation or using Gaussian elimination or something like that. The one that we're going to employ for a problem like this is going to be substitution. So to do this substitution, what I'm going to do is I'm going to get one of the two variables by itself in both equations and then just set the two equal to each other. I feel okay? So if I look at equation, let's call this one, the top one equation A and the other equation B. I'm going to do my cross multiplication thing. And I have x equals tan 32 degrees equals 100 plus y. And if I do the same thing for equation B, I have x equals tan, that's right, as y times tan 37.5. Notice both of these two equations are equal to x. So what can I do with that? I can substitute. I can set them equal to each other, right? Since they're both equal to x. I don't know why I wrote that. It's dumb. So far, so good. So now I've gone from having an equation with two different kinds of variables in it to just one kind of variable in it, right? This equation now has just y rather than x and y. The problem, though, that I still face is that my y's are in two different locations, right? So my next order of business is going to be to get the y's on the same side of the equation. Probably the easiest way to do that is to distribute the tan 32 through so far so good there. And now I'm just going to subtract the y tan 32 from both sides. Now, can I subtract y tan 37.5 and y tan 32? How would I do it? What's up? What do you mean convert them? Okay. So, yeah, that's the right idea. What Nick says is that, well, tan 37.5 and tan 32 are just numbers, right? Those are just, that's a number I type in my calculator, I get a decimal. I'm just going to be subtracting those two numbers. So I can think about that coefficient on the y as really just tan 37.5 minus tan 32. Right? I'm going to avoid typing it into my calculator because I don't want to hang on to all the decimals. I'm just going to write it that way. Is that okay? But that's absolutely the right idea, is I just think about them like these are just coefficients. And now I'm going to divide both sides by that coefficient. Again, that coefficient is just some decimal, but rather than hanging on to that decimal, I'm just going to leave it all this way, so I only have to type in my calculator and round one time. So that's the y, separated, right? Let's get that into our calculator and get a decimal for that now. So here's a place where that fraction command that I've shown you guys really would be helpful to us, right? This is going to need a boatload of parentheses if I try to do it on one line. So instead, I'm going to press alpha y equals, and then choose option 1 to get that horizontal fraction bar. And then we'll do 100 times tan 32 divided by tan 37.5 minus tan 32. And then press enter. 438.6. And I think our unit here we were using was meters. Now, what were we trying to solve for in the problem, though? Because we had two variables here. We had an x and a y. What were we really looking for, though, in the problem? Let's go back and read. Oh, yeah, we were looking for x. They want how tall. That was our x. Shoot! Well, how are we going to get x if we have y? Yeah, well, I'm just going to plug it back into either equation A or equation B, right? Which one looks more appealing to you? I agree. Why? Just less stuff going on, right? So we'll take tan 37.5 equals x over, and then instead of y, I'm going to do my 438.6. Do my cross multiply thing, so x equals 438.6 times tan 37.5. And then it's just calculator time, my dudes. So I'll take that last answer and multiply it by tan 37.5. There we go, 336.6. What do you guys think? Not too bad, right? All right, this is where we're going to stop here today. So let's review what we've assigned so far. For problem set 1, we had worksheets 1 and 2. We've already checked that. Problem set 2, that's what's due on whatever, it's like the 19th or something. Does that sound about right? Yeah. So that's going to be worksheet 4, and then 1 through 16, and the delta math. And then this problem set, we're going to assign worksheet 3 and 17 to 23, and the review, that'll all be on the same problem set. Everybody feel okay about due dates and what's due when? Oh, one more thing. What's due Friday? Yeah. That half sheet. Today is Thursday. That is tomorrow. My suggestion to you as you're putting your half sheet together, this example problem that we just did, where we had to solve that system, or problem 6 from the worksheet, where you'll have to solve a system, or problem 7 from the review, where you'll have to solve a system. I might have one of those as an example on my half sheet so I don't get lost in the sauce on that, where the algebra there gets a little complicated. Be nice to have an exemplar to look from. AJ.
Is the first, the 8A test, is it tomorrow or no?
So tomorrow's the review day. The half sheets we'll collect at the end of class. The day we get back, I'm going to do the first section of chapter 5, the class we get back. And then we'll have our test on the second class day after vacation. because it feels just kind of like a bad idea to come back from vacation and have a test.
So it could be like, our note cards.
I want them on Friday because to be honest with you guys, you've all been waiting to last minute, and I look at some of your note cards and they're really bad. Like I want us to there's a hard due date on this. Stop waiting to last minute. Let's build these in advance. I'm going to tell you it's due, and I mean it's due this time. Just going to see how that goes to see if we get a little bit better quality out of our note cards. And that's my justification for wanting to do that. And I don't think that anybody's going to remember to do one over vacation, to be quite honest with you guys. This is me trying to help you. You know what I mean? It doesn't feel like help, but I promise you it's for all of your benefit to do this now and just have it done. You know what I'm saying? And that's it for me. I'm done talking. Are you guys feel okay? So you can take the remainder of our time to work on any or all of these outstanding assignments, the new stuff we just assigned, the stuff that you have backlogged, work on your half sheet, ask me questions, do some math in general, be productive here. Everybody cool? Okay, I'm going to stop talking.